welcome to Ask a Physicist, the show on YouTube providing you with interesting and practical information from the world of physics. Now, some of you may be wondering, what should you ask a physicist about? Well, you'd be surprised how many problems there are which can easily be solved when considering them from a physical point of view. Now, since no one's actually asked any questions yet, I'm just going to start you off with an example of an age-old question many of you may have been wondering about. The question is it possible to see the Great Wall of China from space? Interestingly enough, we don't actually have to go into outer space to answer that question. As a matter of fact, a few simple calculations will be sufficient. Now, the crucial element we have to take into consideration here is the angular resolution of the human eye. Now, many of you will have noticed that whenever you move away far enough from any given object, you will eventually cease to be able to see it. This is because the angular resolution of the human eye is restricted for some people so badly that they need glasses in order to see over greater distances, like myself, for instance. Now, let's consider the example of a person watching a spherical object. Well, a ball, for instance. You see that the eye of the person forms an angle with the width of the object. Now, as the width of the object decreases, or when it is moved away from the person, this angle will decrease. Now, if we move the object away far enough, we will reach the point at which the person won't be able to see the object any longer. The angle at which the person is just able to make out the object is the angular resolution of the person's eyes. Well, I hope you're all still with me so far. Now, the angular resolution of the human eye is said to be approximately 1 arc minute, or 0.017 degrees. 1 arc minute, by the way, is 1 degree divided by 60. Now, I hope you all know what a degree is. If not, well, here's a simple explanation. Just imagine you had a full circle and you divided it into 360 equal pieces. Each of these pieces would constitute for an angle of 1 degree. And hope that makes things clear.
Now, let's get back to the original problem. First of all, we need to clarify what is meant by space. Well, the officially accepted height of the boundary where the atmosphere stops and space begins, known as the Kármán line, is 100 kilometers or 62.5 miles above sea level. We also need to consider the dimensions of the Great Wall of China. As many of you know, it is thousands of miles long. However, for our question, this is actually quite irrelevant. I mean, you could span a piece of string from China to the United States, and although that's incredibly long, you still couldn't see it even from 100 meters distance. No, what matters here is the width of the wall, which ranges from 5 to 9 meters. Now then, the question we ask is, if you were suspended in space 100 kilometers from the surface of the Earth, straight above the Great Wall of China, which we assume to be 9 meters wide, and you looked at it, what would be the angle formed by the width of the wall and your eyes? And how does it compare to your eye's angular resolution? The method we use to find this out is called small angle approximation, which is a simplified yet sufficiently accurate method that avoids all the tedious trigonometric equations. Well, all we have to do is take the width of the wall and divide it by the distance to space, and what we get is the angle we were looking for in radians. Now, to get the result in degrees, we simply divide by 2 pi and multiply by 360, and we get 0.0052 degrees, which is about equal to 0.3 arc minutes.
Now, if you remember, the angular resolution of the human eye, or in other words, the smallest angle we're able to make out, is about 1 arc minute. So, in conclusion, unless your eyesight is about 3 times as good as that of an average human being, you will not be able to see the Great Wall of China from space.
Now, although we clearly can't see the wall as such, there are other factors that need to be taken in consideration. Shadows, for instance. If the wall casts a shadow to its side, it may be easier for us to make it out. Also, one should consider the shape of the terrain around the wall and the weather conditions, since they both could have a negative or positive effect on the wall's visibility. However, I'd say everything indicates that if you ever decide to go into outer space to have a look at the wall, you will probably be disappointed, just like Yang Liwei, the Chinese astronaut who tried just that. On the other hand, though, there are structures which are much more likely to be seen from space, like the pyramids, for instance. In fact, even a simple shopping center would be much more suitable in this respect.
Well, that's all for this episode of Ask a Physicist. I hope you enjoyed it. And please do feel free to now ask a question yourself, either by sending me a message, by adding a comment, or even by posting a video response. And I will get back to you next time. Till then, see you.